What's up everyone, it's that Math Magician, and on this video we're taking a look at systems, and we want to see can we use the elimination method to find out where the two lines intersect. So let's go ahead and jump into this problem. I have these two equations here, 3x plus 4y equals 1, and then 2x plus 4y equals 2. And we want to see, can we use the elimination method for this? Now remember, for elimination method, we want to identify a variable that will get eliminated. And if I'm looking at the x's, I don't think these are going to get eliminated that easily. One has a 3, one has a 2. Those numbers aren't the same, so that would be really difficult for us to get them eliminated. Like, we could do it, but it would require more steps. But if I look at the y variable, notice that the coefficient is exactly the same. One is positive 4 and the other is positive 4. Now, man, it would be really nice if one of those was negative, right? Because if one of those was negative and I put the big plus sign and the equal sign underneath, they would get eliminated because one would be positive 4, one would be negative 4. But as it stands, right now, if I tried elimination method, notice that nothing would get eliminated. It actually makes this problem a little more complicated because I still have two variables. But here's the thing, right? We were talking about how we want to have one of the y's to be negative. If one of the y's are negative, our life would be easier. Well, then we can do that. That's exactly the step we want to do. Let's take the bottom equation. It doesn't matter. You could try it on your own. Take the top equation and try the same steps. But for the bottom equation, I'm going to multiply it by -1. I'm going to multiply by -1 because I want to turn this y variable negative. So let's go ahead though. I have to though take every term and multiply it by -1. I can't just do the 4y. I got to do everything on the bottom. So -1 times 2x makes -2x. -1 times positive 4y makes -4y. And -1 times 2 is -2. Let's go ahead and rewrite that top equation. We're not even touching the top equation. We like it the way it looks. And look what we've done. All we've done is multiply that bottom equation by -1. Now, when I put my big plus sign and my big equal sign bar there for elimination method, the y's are going to cancel. They're going to eliminate. They're going to add to 0, however the way you want to say it. But I'm going to scoot this over so we can knock out this problem. Let's add them together. Y's are eliminated. They made 0 y's. 3x plus -2x is actually just 1x. And then we're left with the equal sign, and 1 minus 2 is -1. We have solved for that x variable very quickly, all because we decided to multiply the bottom equation by -1. So that the y's would cancel out or eliminate. This is how you want to use those problems. Alrighty, now here's my next step. I solved for x. Don't forget that we also need to solve for y. So now I need to pick one of those equations. It doesn't matter which one. And I need to throw back in that x is -1 to solve for y. So I'm going to go ahead and use the top equation. It looks a little easier. There's no negatives in there. But instead of writing x, I know what x equals. X equals -1. So I'm going to substitute that x equals -1 into my x variable right there. Awesome. Now all we got to do is solve for y. All right, 3 times -1 is -3. All right, I want to move that 3 over to the other side. So I'm going to add 3 on both sides. And I might be running out of room here, but I think we'll be able to make it work. 4y is going to equal 1 plus 3, which is 4. Whoops, I somehow got on the highlighter. Let me switch this back. And last but not least, as I zoom out and scoot up, I want y by itself. We'll divide both sides by 4, so y equals 1. We have solved for y after we figured out what x equaled. That means these 2 points here intersect at the point -1, 1. Alrighty, y'all, you did so good with elimination method. Don't get afraid. When you try it, nothing gets eliminated. We can manipulate these equations to be whatever we want them to be. Alrighty, y'all, it's that Math Magician, and I'll see you on the next video.